Our sense of touch is not uniformly distributed across our body. Certain areas are far more sensitive than others. For instance, while the soles of our feet don't rank high in sensitivity, our hands and lips are prominently represented in the somatosensory cortex. To gauge tactile sensitivity, researchers use a double-tipped instrument to determine the minimum distance at which the tips can be perceived as separate points of pressure. The somatosensory cortex functions like a body map, with distinct regions dedicated to processing stimuli from various body parts, such as the feet or arms. Just like our other senses, touch can be prone to illusions and misinterpretations. A fascinating example is the Aristotle illusion, as discussed by Dean Burnett in his book The Idiot Brain. Our brain's ability to identify objects by touch relies on its awareness of finger positions. If you touch a small object, like a marble, with your index and middle fingers, you'll perceive it as a single object. However, if you cross those fingers and close your eyes, it feels like you're touching two separate objects. This occurs because there's no direct communication between the somatosensory cortex, which processes touch, and the motor cortex, which controls finger movement, to resolve this sensory contradiction. Closing your eyes prevents visual input from correcting this false perception. Moreover, our body houses various types of touch receptors, each named after their discoverers: Pacinian corpuscles for pressure, Filippo Pacini, 1830, Meissner's corpuscles for touch, George Meissner, 1853, Krause's and bulbs for cold, Wilhelm Krauss, 1860, and Ruffini endings for heat, Angelo Ruffini, 1898. Each plays a distinct role in our complex and fascinating sense of touch,